we are studying the physical methods for characterization of solids, and we have previously studied the X-ray diffraction analysis, neutron diffraction analysis, which give information about the structure of solid. Here is another technique, that is electron microscopy. It is also used for studying the structure of solid materials. The central player electron. In electron microscopy, there is the central role of electron. You know that electron is the elementary particle of the material. It is also called corpuscle. It carries a negative charge, and it was discovered by J.J. Thomson in 1897. The electron is constituent of atom. It is 1,000 times smaller than hydrogen atom, and the mass of electron is 1 over 1836 times of that of proton. The electron is particles, but it has wave-like properties. In 1924, the wave-particle dualism was postulated by de Broglie, and you have already studied the de Broglie equation. As moving particles have wave properties, with the wavelength lambda being inversely related to the momentum p by, here is the lambda wavelength is equal to Planck's constant divided by momentum. Momentum is mv. So momentum is the property of the particle, and lambda is the property of wavelength. So wavelength and momentum are inversely proportional to each other. The wavelength. Resolving power of electron microscope is from wave properties of electron. Resolving power means the detail of structure. The higher the resolving power, it will show more detail of the material structure. So this resolving power depend on the wave properties of the electron. Limit of resolution is indirectly proportional. Indirectly proportional means it is inversely proportional to the wavelength of illuminating light. So longer the wavelength, it means the when the wavelength of illuminating light is greater, its resolution will be smaller. Here is the equation. Lambda is equal to 150 under root divided by V, and lambda is the wavelength in angstrom. V is accelerating voltage in volts. Here this diagram show the difference between wavelength and amplitude. Electron wave. The generation of monochromatic and coherent electron beam is important. Design of modern electron microscope is based on this concept. This is coherent beam. This is non-coherent beam. So, in electron microscopy, a monochromatic beam of electron and coherent electron beam is used like this. And the modern electron microscope concept is based on this monochromatic and coherent beam of electron. Scheme of electron matter interaction. Here this is the incident beam of electron, and this is the material specimen. So these electrons can interact with this matter in different ways, and here are different possibilities arising from impact of electron beam onto the specimen. A signal below the specimen is observable. Thickness is small enough to allow some electron to pass through. This specimen will be observable in the electron microscope if some of the electron will be passed without absorbing. They will pass, and this specimen should be very thin, so some of the electron will pass from this material. An image of this material will be available, will be formed in electron microscope. So there is different principle in there are different types of electron microscopes, and different principles are involved in electron microscopy. So here are different type of interaction of electron with the specimen. So first is here, this is secondary electron. Secondary electrons are those electrons which are emitted from the specimen. When incident electrons strike with the electrons of the specimen, the electrons of specimen are rejected, so secondary electrons are produced. These are primary electrons, and secondary electrons are the electrons of the specimen. The X-rays can also be produced when the incident electron beam strike with the specimen, and we have already studied how X-rays are produced. Backscattered electrons are scattered back in the same direction or same site where there is incident. They are not passed. Agar electrons are those electrons which are not emitted. These secondary electrons are emitted from the outermost shell of the specimen atoms. And the agar electrons are also the electrons of the specimen, but these are not emitted from the outermost shell. These are emitted from the inner shells of the specimen atoms, and these type of electrons are called agar electrons. Here, these three types of electrons are they pass from the specimen, and here this type is elastically scattered electrons. The elastically scattered electrons are those electrons. The elastically scattered electrons can be defined as these are those electrons which are scattered by the constituent atoms in the specimen without losing their energy. And inelastically scattered electrons are the opposite, that is, they will lose some amount of energy. And direct beam, that this beam will directly pass and this beam will not change that direction. Elastic electron interaction. In elastic electron interaction, that is interaction of electron with a material that is elastic, there is no energy gain or no energy loss. No energy is transferred from the electron to the sample or from the sample to the electron. These signals are mainly exploited that in electron microscope. Signals due to elastic electron interaction will be obtained, and these signals are exploited in transmission electron microscopy and electron diffraction methods. Transmission electron microscopy is a type of electron microscopy, and it will work on the principle of elastic electron interaction, and electron diffraction method also work on the elastic electron interaction methods. Inelastic electron interactions. Inelastic electron interaction with a specimen is that in which the electron lose some amount of energy and transfer this amount of energy to the material or to the specimen. Energy is transferred from the electron to the specimen. The energy transfer can cause different types of signals, different type of changes can be produced in specimen, and due to which different types of signals can be produced. X-rays can be produced from the specimen when the electrons strike with the specimen and inelastic electron interaction takes place. Auger electron can be produced. These are the electrons ejected from the inner shell. Secondary electrons can be produced. These are also the electrons of the specimen which are produced from the specimen. These electrons are removed from the outermost shell. Plasmons can be produced. A plasmon is the quantum of plasma isolation. Uh, in case of metal, there are free electrons and positive ions, so this can be considered as plasma. And this plasma is oscillating, and when this plasma is oscillating, the quantum of this plasma oscillation is called plasmon. And in the same way as the quantum of light is called photon, the quantum of plasma oscillation is called plasmon. And the next is phonon. Phonons can be produced when there is inelastic interaction of the specimen and the electron. And what is phonon? Phonon is a collective excitation in a periodic elastic arrangement of atoms or molecule in condensed matter. Means the matter is excited, and in excited form it is called phonon. UV radiation quanta are produced, UV photons are produced, or cathodoluminescence is produced. Cathodoluminescence, how it will happen when the electrons strike on the luminescent material. The material should be the specimen when the specimen is luminescent. So on the luminescent material, when the electron will strike, the material will show fluorescence. and this type of signals are called cathodoluminescence signals. And this inelastic electron interaction is used in analytical electron microscopy, that is SEM. SEM is a type of electron microscopy, that is scanning electron microscopy. What is electron microscopy? Electron microscopy is a diagnostic tool. It is used for investigation of structure. It is used in biology as well as in material chemistry for studying the nature of the material, for studying the structure of the material. It with diverse combination of techniques that offer unique possibilities to gain insight into the following information can we get. We get the information about the structure, topology, morphology, and composition of the materials. We can get these type of information from electron microscopy. Electron microscopes are used to study the objects whose dimensions are less than 0.2 micrometer. It is used for analysis of subcellular structure, intracellular pathogen, viruses, cell metabolism, study of minute structure in the nature. In the material chemistry, it is most widely used. It is a characterization technique of the material, especially nanomaterial, are characterized by electron microscope. Greater resolving power of electron microscope than light microscope. Only light microscope or ordinary light microscope has very less resolving power. Electron microscope has very high resolving power. An electron microscope can magnify the structure from 100 to 250,000 times than ordinary light microscope. Why were the electron microscope are invented? Here are different structures. This is macrostructures, unaided eye. We can see these type of structure with our eyes. Light microscope, the big structure can be seen with light microscope, and the from 100 nanometer and below 100 nanometer structure can only be visible by electron microscope.